All right, so I thought as I was making some videos on infinite series, it'd be nice to have a video that's sort of a review of the most basic ideas behind infinite series. Okay, so the way I'm thinking about this video is what is an infinite series and what does it mean to converge or diverge? Okay, so I want to get these concepts down, converge or diverge. So we'll look at this one, and I want you to get a feel for the numbers, because this is math after all. And I mean, you can think of math in terms of theorems and rules and so on, but it's better if you have a feel for what's happening with the calculations and what the numbers are doing, okay? So this is not a complex theoretical video with lots of rigor. I'm just trying to get your intuition in the right direction. So look at this series. What's this one? 1/2 to the n power. That would be 1/2 plus 1/4 plus 1/8, right? It just do the math. Keeps going. Does it ever end? No, suppose it goes forever. All right, suppose it goes forever. 1/2 plus 1/4 plus 1/8 plus 1/16, and you keep going and you never stop. Imagine that. Now, let's say you see how a series is... well, we're adding a bunch of terms together. To do this computation, we would do 1/4, 1/2 plus 1/4 plus 1/8, and so on, forever. Let's see if we can get a grasp of what happens at forever. We're mortals, and we'll never make it to forever, okay? But I can maybe get an idea what would happen if I went forever. So here, S sub n is the sum of the first n terms. That's how we always use our notation with an infinite series or a finite series. So say I let n be 3. S sub 3 is the sum of the first 3 terms. All it means is, what would you get if you took 1/2 plus 1/4 plus 1/8? That's what the partial sum S sub 3 is. That happens to be 0.875. Now that alone doesn't tell me anything. If I add the first 3 terms, it just doesn't give me a very good idea what happens at infinity. But say I add the first 7 terms, I get 0.9922. And say I add the first 15 terms, can you imagine doing that? Taking this 15 terms out, adding them all together, I'll get 0.9999. Now, what do you think? I mean, do you see a pattern here? What does it look like happens the more terms you add together? It looks like the more terms you add together, your answer, your grand total is like running up against 1. You could keep going. You can add the first 16 terms together. Tell me what you get. Add the first 17 terms together. Tell me what you get. You'll be running up against 1. Okay? So when I see this, I would say, well, it looks like it's going to converge to 1. Okay? And I'm not saying that the numbers are 1. I'm just saying when you add them up, the grand total is running up against 1. You'll never actually get there. Okay? All right, so we'll say it converges to 1. Another way that people say this that might not be as intuitive for you is they'll say the limit as n goes to infinity of the partial sums is 1. All right? You can think of it like that if you want to, but I mean, just look at it. The more terms I add, the closer my answer gets to 1. But I never quite get there. Okay. All right. Now this is also, you could see this as a geometric series and prove it converges to 1 that way too. It's true. It is geometric, and it will converge to S is A1 over 1 minus R, and that will be 1. Okay. So Sn is the partial sum. And this number that we say it converges to is S, okay? So Sn, a partial sum, S is the infinite sum, okay? It's the limit of the partial sums, you could say. All right, now do you have a feel for the numbers? That's what I wanted you to get out of this. Let's look at 2 more. What about this one, okay? Series from 1 to infinity, negative 0.8 to the n power. Well, let's look at the partial sums. First 3 terms add to negative 0.672. What am I saying there when I say S3? The partial sum S3. I'm saying if you took negative 0.8, okay, plus 0.8 squared minus 0.8 to the third power. Okay? That would be the numbers that you'd get if you looked at the first three terms. All right, if you did that, you get negative 0.672, okay? That's what a partial sum is. If you add the first 15, negative 0.46. If you add the first 16, negative 0.43. So it's like up a little bit, down a little bit. And then here, up a little bit, down a little bit. But where are these numbers going? I mean, if I just look at the tenth place, I'm looking at 0.4. It looks like it converges to about negative 0.44. I mean, it's kind of going up and down and up and down. And that makes sense because it's alternating. So you're subtracting, but then you're adding, and then you're subtracting, but then you're adding. So the grand total is going to go up and down and up and down. So it's sort of like this. You can think of it this way. There's this number S that it converges to. And it looks like, S15 is a little bit high. And then S16 is a little bit low. And then S25 is just a little bit high. But then S26 is a little bit low. But they're approaching something. It looks like it's about 0.44. Okay? So what do you think? Or what do I think? I would say, well, it looks like it converges to, I don't know, about 0.44 negative or so. That's the pattern I'm seeing. But, I told you I wanted this to be a video that's fairly basic. And I'm not saying the numbers in this series are 0.44. I'm just saying the more of them you add up, according to the numbers you get in the series, the closer your grand total gets to about negative 0.44. Now, well, let's see. What really does it converge to? Like, this is just kind of an about answer from what I'm seeing. It is geometric. And S is A1, negative 0.8 over 1 minus R. What's R in this series? R is negative 0.8. So there's what the series converges to. We go ahead and calculate that and just confirm it with our table. So negative 0.8 divided by 1.8. And I get 0.44444.4 repeating. And I guess if you wanted a fraction, it'd be 4 over 9. That's 8 over 10, and then this is 18 over 10. And we can divide it, cancel. We'll get 8 over 18 and 4 over 9. Okay, but anyway, yeah, that's it. That's it right there. That number is about 0.4 bar, however you see it. Right? Looks like that's where we're going. We're kind of dancing around that number. So S is 0.4 bar. We're a little high. Sorry, negative. I'm sorry. I've been making videos all day long. That's no excuse to be sloppy, but it's true. All right. So yes, we're kind of dancing around negative 0.4. Being a little too high, and then a little too low, and then a little too high, and then a little too low. That's the nature of this series, being an alternating series. That's how the partial sums approach the sum, S, okay? All right. So, but again, I wanted you to just look at the numbers and get a feel for what it means when we say a series converges, okay? So when I make the final statement that this series converges to S equals 0.4 bar, negative 0.4 bar, then you got to feel for the numbers. Sorry, I keep forgetting the negative, but there it is. Okay, so let's look at one more example. So we've seen two that converge. They converge in a little bit different ways. Here I'm like getting bigger and bigger and bigger as I add up to 1. And here in this alternating series, I'm a little high and a little low and a little high and a little low as I add up the numbers, but the grand totals approach negative 0.4, okay? So we see two that converge. Let's look at one that doesn't. What about this one? The partial sums they're just wild. They're all over the place, okay? Now, I would say that, well, this one is not like the others. It doesn't look like the more terms I add, the closer I get to something. I add the first 3, I get negative 6. I add the first 10 terms, I get 682. But then I add one more term, the sum of the first 11 terms, negative 1,366. It does not look like the more terms I add, the closer I get to something. Well, that's just one example of a series that diverges. All right, so this one diverges. It's not like the other one. Okay, it's not true that the limit of the partial sums is anything. If you were going to say, what's the limit as n goes to infinity of Sn, it does not exist. There is no limit. I don't see any pattern here as I add more terms together, as n gets bigger. Okay? All right. Real quick, another series that would diverge would be like this one. This one will be pretty easy, right? You should see that one diverges. And again, for this video, I really just want to look at the numbers so that you get a feel for what happens in a series. Because many people who take calculus 2 confuse the partial sums with the terms. All right, and I don't want that to happen for you. When I say that the partial sum is 0.999 or that it converges to 1, I'm not saying any of the numbers are 1, right? I'm just saying if you add them up more and more, that's what the grand total starts to look like, okay? So, well, let's look at this one. Why not? N and Sn. Does this series converge or not? 3. What's the sum of the first 3 terms? What the series is? Negative 1 plus 1 minus 1 plus... That's what it looks like. Sum of the first 3 terms is negative 1. Sum of the first 4 terms is, so if I add it, so negative 1 plus 0, right? Okay. If I add an odd number, it's negative 1. If I add an even number, it's 0. But if you went ahead and added the first 5 terms, it'd be negative 1. If you added the first 6 terms, it'd be 0. It's not like the more terms you add, the closer you get to something. It's not like this one. And it's not like this one either, all right? It diverges. I mean, it doesn't look, when you look at the numbers, it doesn't look like that one, like this one versus this one. But we can agree that there's no limit as n goes to infinity of Sn. We can agree that the more terms you add, it's not true that you get closer to some number, like those first 2 examples that converge, all right? Now, this is just a numbers video, really. In practice, how are you going to decide? How are you going to decide if a series converges or not? Well, it may be geometric. It may be a piece series. It may be an alternating series. And each of these have like their own conditions for if they converge, all right? But when we say a series converges or diverges, this is how I'm thinking about the numbers, and I want you to think about that, the numbers too. I'm not saying that you have to make a table to demonstrate it to yourself every time, but at least mentally you're aware of what happens as far as the calculations go when we say a series converges. Now, this is not a definitive list. I just wanted to say that beyond the tables, every type of series has its own requirements or test to tell if it converges or not.